Hello guys, hope this video finds you well. Hope you watched my video on linear search. So this was the code for the overall linear search that we discussed in the last video, where we considered in an array of size n, okay, with elements n minus 1 elements. And why did we reject this searching technique? Now because the loop was of n steps, and if n is very large, it would take a very large time to iterate over that array. And we can express this in the terms of time complexity. So time complexity is always, as you know, expressed, okay, in with respect to the input or the number of steps we are taking. Okay, so here we can write, as we are taking n steps to iterate over the array. In the worst case, definitely it will not always happen like you are, every time when you perform linear search, every time you need to follow n steps. But in the worst case, we should work considering the worst case scenario, na? That is why, uh, in the worst case, we are considering a very large number. Okay, so in the worst case, if it takes n steps, so time complexity can be represented as big O of n, right? Because n is the number of steps and big O is the representation. Okay, many representations we have in case of time complexity. Okay, hope you guys know all those, right? So today, for the for this reason, we are going to discuss an optimized approach to our searching technique. That is our binary search. Now, as the name suggests, binary search is a technique in which we actually divide the array into two halves. Okay, so there are actually three conditions for only one essential condition for the binary search. That is, I am giving the heading binary search, and one of the most condition for essential condition for binary search is the array must be sorted. By sorted, I mean to say the elements sorted means the element or the elements should be arranged in ascending or descending order. Mostly we consider the elements are arranged in ascending order. Okay, in descending order also the logic will be same. Okay, with few changes. Okay, but mostly in 99% of the cases the array is provided in ascending order. Okay, by sorted we mean actually the array actually get provided in ascending order, but in reality sorted may mean ascending and descending, both the orders. Okay, that is, the elements actually should not be in a haphazard manner. Okay, like here we have considered a sorted array almost, like 15 should not come after 25 in, and say 16 should not come after 25. Okay, and this way, like here 15 less than 16 less than 20, this way it is arranged in ascending order, the elements are arranged in ascending order. And this is a very essential condition for binary search. Also, you can say it is a disadvantage because in linear search actually it was not necessary for the array to be sorted. Okay, it's a coincidence that the array which I considered was sorted, but even if I don't consider, because it is just comparing with each element, so it will definitely find out the element for you. Okay, But even after this disadvantage of binary search, it is an optimized process of searching, because there are also algorithms, different various algorithms for sorting. Okay, for that you need to actually attend my regular Google Meet classes. We will discuss there. That is, for example, say by bubble sort. Then we have selection sort, then insertion sort, which arranges the data in the array to the sorted form. Okay, so that we will discuss later in some other videos or classes. Here our primary topic is binary search and how to execute it. So let me consider the same array. Say ARR is equal to 15, 16, 20, 25, 30, 35, 40. Okay, now consider it like a book. Say you have a book consisting of around 300 pages. In a book you will notice that your page numbers are arranged in an ascending order, right? Because page number 2 comes after page number 1, page number 3 comes after page number 2, and in this way it goes on increasing. So if I let for example I ask you in that book with number of pages 300 to turn to the page number 155. So will you like turn over each and every page, or we can be like uh, just give a clever approach. Say for example, you turn on to the middle of the book page first. That is, as I said, 155 is my required page number. And so what is the middle of the page? As the book consists of 300 pages, so page number 150 is our middlemost page. Okay, so you open that first, and as I said, like the page number is 155, you know for sure that 155 is greater than that 150, the middle page. So definitely you would not consider a page number to check on a page number that comes before 150, right? Because 155 is greater than 150, so you never again turn on to the left side of that page. You will search on the right half of the book, right? So same approach is in case of the binary search. We consider a first page, okay, that is our index, low index, okay, low. So low may be the leftmost element, absolutely the leftmost element of the array. Similarly, a high, okay. You can take your convenient names. You can also take like left and right, okay. These are also possible names. Just you need to consider two end pointers. Two end pointers. Say this is the first pointer and this is the last pointer. And we will be considering a middle index that lies in the middle of the two, right? So here, if we consider the length of the array is 1, 2, 3, 4, 5, 6, 7. So altogether there are 7 elements. So the last index is 6 and the first index is 0. Right? So say 0. Okay, let me adjust it a bit. First index is 0, 0, then 1, 2, 3, 4, 5, 6. So where do you think the mid index will be? It's a common sense. So 0 plus 6 by 2, right? We can consider mid is the as the half of the like the half of the total size of array. So mid is equal to, we can consider low plus high by 2. Okay. So here comes your mid. Okay. This is your mid. Now in this case, like, let me consider a target. Say my target value is 16. Okay. 16 is my target value. Target is equal to 16. Because if I consider 25 at the very first iteration, you are getting 25 and you will be saying like, okay, so that is not the way. Actually, that is why I'm considering 16. So you need a couple of iterations. Now, how will you check here? So just like the way of book, so I told you 155. So you turned over to 150, that is the middle of the first and the last page. And you knew that 155 was definitely greater than 150. That is why you turn to the right portion of the book, right? In this case, my requirement is 16, right? So if my requirement is 16 uh, greater than or less than 25 or equal to 25? It is definitely 16 is definitely less than 25, right? So which portion of the array now we should consider for searching? Okay, we shouldn't now no more search the whole array, right? Because that will be an unnecessary number of iterations. Therefore, we should skip this right portion of mid, because 16 is less than mid, and so we know definitely as the array is sorted, so 16 shouldn't lie on, this is not 16 and 16 is less than 25. It is for sure that 16 doesn't lie on the right portion of the 25, right? Therefore, we skip this right searching space. And how do we skip it? So high is equal to mid minus 1. High. So as target is less than array of mid, high is equal to mid minus 1, right? So I'm redrawing this array. Now this is your new array. Array is equal to, okay, 15, 16, 20, 25, 30, 35, 40. Okay. And in this, and now high is equal to mid minus 1. So high points here. Low. Okay. And high points here, that is on 20. High points here to 20. Okay. And here we have mid. Okay. Now if we check ARR of mid, ARR of mid, that is equal to 16, and so 16 equal to 16, and we got our element, required element, right? Therefore we return the value of mid, because mid is the actual index, that is the required where this element, we are having this element, right? Similarly, now if I give the target value to be say 50, as you know, target value to be 50. Okay. So 50 lies nowhere in this array. Okay. Therefore, we just begin from the beginning. Okay. So this is the target. Target is equal to 50, and consider this was your original array, right? If this was your original array, now say 50, if we just ordinarily compare, 50 is greater than 25 or less than 25? 50 is definitely greater than 25, right? So we consider that we shouldn't consider the left searching space, and we consider the right searching space similarly, right? Therefore, low is equal to mid plus 1. Okay. So low is equal to mid plus 1, right? We redraw this array. Here is equal to 15, 16, 20, 25, 30, 35, and 40. Okay. Right. And let me consider this low to be here. Let me consider this low to be pointing here again, and this high is pointing here again at the last, because we are considered from the beginning. So that is why high will be again pointing to the last point. Okay. And need to be here. So now if I consider, so again target is equal to 50. Okay. Sorry, target is equal to 50. Therefore 50 is greater than 25, and we skip the left searching space. Okay. So we can skip the left searching space, and my low moves to the to mid plus 1, because from low to mid, that is less than 25, and 50 is not less than 25 definitely. So we can move our low after mid. Okay. That is low points next here after mid. So this is the point where low points, right? And our mid comes in between low and high. So index of low was, so it is 0, 1, 2, 3, 4, 5, 6. 4 plus 6 by 2. 0, 1, 2, 3, 4, 5, 6. 4 plus 6 by 2. That is 10 by 2, and it's 5. So 4 and 6, and here it's 5. Therefore mid points at index 5, that is 35. And we can move our mid here now. It is, this is where our mid comes. Now again, so 35, is 35 less than 50 or greater than 50? Definitely 35 is less than 50. Therefore, as 35 is less than 50, we again do not consider the left searching space. And if we don't consider left searching because the value is less than 35, so it looks here we have one value. Okay, because here we could have had 31, 32 or something like other values. So in the left searching space, we can't have any more value. As 50 is greater than 35, so 50 must lie somewhere after 35. That is why again low comes, again low should point after mid to 40, right? So here comes our next value, that is error. Let me redraw this array. 15, 16, 20, 25, 30, 35, 40. So low points here now, low, and high also, as it was here only, both points in the same index, and also the mid, because now 6 plus 6, 12 by 6, that is mid also points here. Mid also points at the same index. So you're every time you're comparing with mid, this time also we compare with mid, value at mid. So error of 40, I mean error of 6, that is 40, is 40 less than 50 or greater than 50? It is less than 50. Therefore, we again do not consider the left searching space. That is, 50 shouldn't definitely lie somewhere on the left side. It should lie somewhere on the right of 40, right? And on the right of 40, we actually have no elements. But how will our system understand this? Now, in order to search for 50, it will try to skip the left searching space. And how we skip our left searching space? That is low is equal to mid plus 1, right? Low is equal to mid plus 1, 30, 35, 40. Low is equal to mid plus 1. And now in this case, high actually points here to index 6. High points here to index 6. And low points somewhere here. That is at index 7. And index 7 doesn't exist in the array. But the major factor here which lies is that low crosses high. Till the time we are making comparisons here, low was less than high in all the cases, right? That is, but in this case, low crosses high, where we will be stopping our iteration. And we found no such index where 50 lies, and therefore we are going to return -1, right? Therefore return -1. Okay, so in this case you may be thinking that when low crosses the boundary of the array, low crosses the boundary of the array, at that time we should stop. But that is not the case. In some other cases, it may so happen that low doesn't cross the boundary of the array. You can try out with other examples by your own. So it may not cross the boundary of the array, but if the element does not exist, it is surely to cross high, right? It will surely cross high. Therefore, when we cross our high index high, we are going to stop the loop. Actually, our searching space can be considered from low to high. Okay, and if somehow we cross high, the low somehow cross high, that means that is an obviously that is invalid, because page number 1 cannot come after page number 150. So therefore, we stop there. Okay, so I am writing the pseudo code of binary search here. In my upcoming videos, I shall be sharing the code for linear search and binary, both linear search and binary search. using Python and C programming language. Okay. So here again we consider two arguments passed by the user. So binary search, int ARR, and int say the target. Okay. And also the size. You can also take the size of the array as an argument. And taking here, say n, where you will from the main function, if you are using, if you are a C programmer, you can pass the size of the array. And if you are a Python user, you can directly call this function with the list. Okay, instead of array, we can consider a list with the target value and the size of the array as n. So int low is equal to 0 and int high is equal to n minus 1, the size of the array minus 1, because that is the index we consider. So now we are searching from low to high, therefore we can consider a loop going from low to high. Okay, because our searching space ends when low crosses high, right? Our searching ends when low crosses high, therefore while low less than equal to high, we can say int mid is equal to low plus high by 2. Okay. Now, actually, directly writing this low plus high by 2 also has some disadvantages uh, that will be discussed in my upcoming classes. If you join, okay, in my upcoming classes, right? So, the disadvantage of this writing this low plus high by 2, we can't always directly write this low plus high by 2. Okay, you can predict this. And now we consider, so if array of mid equal to the target, hmm, so in this condition we found the element, we can return the mid value. Okay, so let me take it int return the value of mid index. Otherwise if the array of mid is greater than the target, that means the array of mid is greater than target, so we can say our searching space on the left side, if array of mid is greater than target, that is target less than the array of mid, we can say that our value surely doesn't lie on the right side, on this right portion of the mid. Okay, as we considered here. Okay, if this is my mid, on the right portion of the mid, we can't say that the value lies. Okay, say in this case, when ARR of mid was 25 and target was 16, in that case 16 didn't lie on the right side, so we can skip the right searching space by saying high is equal to mid minus 1. Okay, and otherwise only one condition lies, that is else low is equal to mid plus 1. That's all about our binary search. And if this loop somehow stops and we couldn't return out of the function, that means the value was not there in the array, and we can return minus 1. So that was all about the binary search. In my upcoming videos, I will be showing you taking more examples of arrays, and we will be discussing the time complexity of binary search. By the way, I can write it here. The time complexity is big O of log n, but how we are getting this, I will be discussing in my upcoming video along with the codes of linear search and both linear search and binary searches. Thank you.